Okay, let's take a look and see how you did on these. So for the first one here, what is the relationship between those two angles? Well, this is a straight line, so those two angles are... Careful. They add up to 180, right? They're called supplementary. So they're supplementary angles. So we know that 3x plus 29 plus 2x plus 1 has to add up to 180 degrees. And now we can just go ahead and simplify and solve. Now remember that first step I said was simplify, which is just combining what we can combine. Bless you again. So we can combine the 3x and the 2x to make 5x. And we can combine the 29 and the 1 to make positive 30. So 5x plus 30 equals 180. Now I'm going to pause there. Any questions on where this equation came from to begin with up here? Okay. Any questions on how I got to this step here after combining everything? Good. Now at this point, from this format here, we should be getting pretty good at solving these. What's the first thing we have to do now to solve it? Subtract 30. Very good, from both sides. So we take that 30 away, leaves us with 5x. 180 minus 30 is 150. And then just divide by 5. So x equals 30. Are we all done? No. We still need to find the angles. So 3x means 3 times 30 plus 39. 3 times 30 is 90 plus 39 is 129 degrees. Over here, 2x plus 1 is going to be 2 times 30 plus 1. 2 times 30 is 60, plus 1 is 61 degrees. Those are the two angles there. All I did is once I found out that x was 30, I replaced this x with 30, and I did my order of operations. Same here, replace that x with 30, and did the order of operations. Questions? Oh, because I added wrong, that should be 119. Thank you. That should be 119. You are correct. The little hamster is not on the wheel yet for the morning. To be honest, it might be one of those days where he just lays by the wheel and tries to swat it with his paw to get through the day. Okay. So 119 and 61 sounds better. Next, number 2 here, this one over here. What's the relationship between those two angles? They add up to 90 degrees. Very good. They are complementary. So we know that 2x plus 11 plus 2x plus 7 has to add up to 90. Now what can we combine there? 2x and 2x make 4x. Anything else? 11 and 7 make 18. So now what? We subtract 18 from both sides. So 4x equals 72. Pretend that looks like an 18 that I subtracted there. And then divide by 4. So x equals 18. Again, we're not done. We still need to find the angles. 2x plus 11 becomes 2 times 18 plus 11. 2 times 18 is 36, plus 11 is 47 degrees. 2x plus 7 becomes 2 times 18 plus 7. 2 times 18 is 36. plus 7 is 43 degrees. So 47 and 43 degrees. Any questions? How are we doing so far? Now, show of hands, how many of you think you could do both of those problems on your own if you had to? Okay. Well, that's a step ahead of where you were half an hour ago. Okay, now this one, what's the relationship between those two angles? They're equal. These are the vertical angles. And not so concerned that you remember the vocabulary, just remember that they have to be equal. So here, instead of adding them up, I am just going to have 4x minus 19 equals 2x plus 7. So now as I go to solve this, the process will be slightly different because my x still appears twice, but it's on opposite sides of the equal sign, opposite sides of the equation. So I can't just combine those and make 6x anymore. What do I have to do? I have to get rid of one of them, and I'm going to get rid of the smaller one, which is the 2x. So I subtract 2x to get rid of it. Now again, you might ask, why am I not dividing by 2? Well, dividing by 2 would leave the x there, and I don't want to leave the x there. I want to get rid of the x as well. So I got to subtract the 2x. I have to subtract 2x from the left side, and the only place I can take it from is the 4x. So 4x minus 2x is 2x. I still have the negative 19. And then add 19. So the negative 19 is gone. I have 2x equals 26. And then divide by 2. X is 13. You got that part right? Good. So now I have to go back and put in 13. So 4x becomes 4 times 13 minus 19. 4 times 13 is 52 minus 19 is 33. I can double check it to make sure this one comes out the same. 2x becomes 2 times 13 plus 7. 2 times 13 is 26. Plus 7 is 33. So that works out. Now you'll notice at the end of each of these I double checked them. I had to make sure these two were equal. I had to make sure that these two added up to 90 degrees. And by making sure these added up to 180, we actually caught a math error on my part. So it is important that you check those answers when you're done to make sure that they come out to add up at least what they're supposed to. Doesn't guarantee you're right, but it'll catch a stupid mistake like my adding error here. How are we doing? Great way to start off a Thursday morning. Oh, it gets better from here, don't worry.
You said your last chapters that you're doing are twice as hard as anything that we've done.
It's better for me from here. How's that? I've explained to you guys that you're here to.
That week off, you got 6 more to go.
I've explained to you guys that you're here to entertain me for 8 weeks, right? Okay.
How are we doing?
You're doing okay.
Just okay?
It's a math class. What makes you think it's about you? Come on. Sorry, I'll be nice for a while. I'm a math teacher. Like I said before, that means I'm not a nice person. I get paid to hurt people.
You're doing a good job at that.
Good. See?
I know when I leave here, every day my head hurts.
There you go. So give that one a shot in your notes. See if you remember how to do that. Okay, so when we're multiplying numbers, we combine the counts. So in this case, we have 7 times 5, which is 35. But then we also combine the names. So we have x squared times x to the 9th makes x to the 11th. Yes, remember when we're multiplying exponents, the appearance is that the powers get added together. Try that one quick. So same concept here. You combine the numbers, you multiply the counts. 4 times 5 is 20. Then we also combine the names. Now when there's more than one name, we can combine each one separately. So we get x to the 7th, good. 4 plus 3 is 7. And y to the 6, good. We think of this as being y to the 1. So 5 plus 1 is 6. Well, since we're having so much fun, of course. Try that one. That's a 1 there. Yeah. Yeah. Give this one a shot. So we multiply the counts, combine the counts, multiply 8 times 2 is 16. I don't know where my 8 came from, but it's a 16. And then y to the 5th. There's nothing else to combine the y with, so it just stays y to the 5th. And z to the 7th. Very good. Well, since we're liking those, try that one. So here we see the parentheses, and of course we have to ask if there's anything to do in the parentheses. And of course, We have x to the third and x squared. We cannot combine those with addition or subtraction. Adding and subtracting, they must have exactly the same name. So then we ask, is there anything that needs to be done to the parentheses? And that is times the 8x. So 8x, oops, put that out there. 8x times 4x to the third is 32x to the fourth. Yes, again, that's like an x to the 1. And 8x times a negative 7x squared is negative 56x to the third. Very good. Bless you. Give that one a shot. I may enjoy my job a little more than I should. Okay, so this is basically an order of operations problem. It just has the algebraic numbers in it. So we have subtraction here and here. There's subtraction in the parentheses here, but we can't do anything with that. So really, that's just a 2-digit number in the parentheses. So the first thing we have to, of course, we see the parentheses, and it should always draw us there first. And inside the parentheses, as we've already said, there's nothing we can do in there. So the second step is, what can we do to the parentheses? That is the multiplication. But we're not multiplying by 3z squared. We're multiplying by negative 3z squared. So the 5z to the 8 up front here does not change. So I'm going to put that in there so I don't forget about it. Then it's negative 3z squared times 9z to the 6th is negative 27z to the 8th. Then I have the negative 3z squared times a negative 4z to the 3rd, which is positive 12z to the 5th. Very good. Negative times a negative is a positive. 3 times 4 is 12. And then z squared times z to the 3rd is z to the 5th. 2 plus 3 is 5. Am I done? No. First of all, what do I have to remember? The negative 11z to the 5th on the end there. Now am I done? No. I still have items with the same name. I still have like terms that I can combine. 5z to the 8th and negative 27z to the 8th. So I have 5, negative 27. So I know that's going to be negative 22. They go opposite directions, so it's the difference in values. And that's z to the 8th. It keeps the same name when I'm adding or subtracting. And then I have the 12 and the negative 11, z to the 5th. Positive 12 and negative 11, that's going to be positive 1, z to the 5th. Why didn't I write the 1 in there? Because I don't have to. We said it's just like having an inch. You don't have to say 1 inch. You can just say an inch. You don't have to say 1 z to the 5th. You can just say z to the 5th. Let's try another one. Try that one and see what you come up with. Just need a minute yet, or are you guys good? Good as it's going to get? Okay. So we look at these. We have enclosing symbols. We have two sets of parentheses. So we're going to go left to right. So we're going to start on the left here with this first one. Anything to do inside those parentheses? No. To the parentheses? Yes. The 4x to the third. 4x to the third times 5x squared is 20x to the fifth. Very good. 4x to the third times negative 3. Negative 12 x to the third. Perfect. Now we go to our second set of parentheses. Anything to do inside those set of parentheses? Nothing to do inside. No. Anything to do to that set of parentheses? Yes, there is. We can think of it as either subtracting what's in there or possibly a simpler way of doing it is to think of that as being a negative 1 times what is in that parentheses. So now a negative 1 times 7x to the 5th is a negative 7x to the 5th. Negative 1 times 12x to the 3rd is a negative 12x to the 3rd. Just like having x, we don't always put the 1 in front of the x, the same here. We don't always put the 1 in front of the parentheses. But when it's a minus in front of the parentheses like that, it's a lot easier to think of it as a negative 1 times the parentheses. It avoids a lot of mistakes. So now we can combine 20x to the 5th and negative 7x to the 5th. What does that make? (13x to the 5th). There you go. 20 and negative 7 gives us 13. Then we have negative 12x to the 3rd and negative 12x to the 3rd. Negative 12 and negative 12 makes negative 24. They both go the same direction. So combine, add the values. Anybody get that? Kind of? Yeah. A lot of times you see the negative 12 and negative 12, a lot of people want to jump at 0.
I got both.
Sure.
I did it again, I got both.
Okay. Okay, well, we're progressing. Now I want to try something, see if you can pick up on it. So the perimeter is 2L plus 2W. If I have a rectangle, pretend that looks like a rectangle. With a length of 3x squared minus 7 and a width of 5x plus 3, can you write an expression for the perimeter of that rectangle? I'm going to give you just a second to think about it. Using this length and this width, can you write an expression using this formula to express the perimeter of that rectangle? Now it would be just like if I gave you numbers here. If I gave you numbers for the length and width, what would you do with L and W here? You'd put the numbers in there, right? Well, I didn't give you numbers, but I did tell you that length is 3x squared minus 7. And I did tell you that the width is 5x plus 3. So just like I would if those were numbers, I would replace those variables with their values. In this case, those values happen to be other letters and numbers, other variables. Now I can simplify this. What can I do to simplify it? 2 times 3x squared is 6x squared. Then I have 2 times negative 7, which is negative 14. Then I move to this set of parentheses. I have 2 times 5x is 10x is positive, so I'm going to put a plus 10x. And 2 times 3 is 6. So again, plus 6. Am I done? No. Now, there's a lot of different things here, and some I can combine and some I cannot. We always want to do something called descending order. It's not wrong if we don't, but it's grammatically more correct if we do. We put the largest power of the variable first. So which digit's going to go first here? The 6x squared. That's the largest power, the 2. What's coming next then? Now it's the plus 10x. And then we can combine negative 14 and positive 6 make negative 8. So P equals 6x squared plus 10x minus 8. What do you think of that one? A little uneasy? Let's try a similar problem once. So I give you the formula that the area of a rectangle is length times width. If I tell you that the length is 5x minus 3 and the width is 4x, try to write an expression for the area. Okay, so the length is 5x minus 3, right? I'm going to put that in parentheses, times my width, which is 4x. Now I can work with it like this, but it might be easier for you if you switch it to put the 4x first. When you're multiplying, you can change the order of the two numbers and it doesn't change anything. But I'm going to do it like this over here just so you can see that it isn't any different. So the parentheses, there's nothing to do in the parentheses, but just like before, there's something to do to it. It's multiplied by 4x. So 4x, just it looks a little backwards now. 4x times 5x is 20x squared. Good, because that's x to the 1 and x to the 1. So 1 plus 1 is 2. And then 4x times negative 3, negative 12x, just x. So it's just nothing times x is just x. So let's say a rectangle has length of 4x squared plus 19 and width of 3x squared minus 7. Express the perimeter. No, it's write an expression for the perimeter, like we've been doing. So perimeter equals 2 times the length plus 2 times the width. In this example, the length is 4x squared plus 19. So that'd be 2 times 4x squared plus 19 plus 2 times the width. The width is 3x squared minus 7. So 2 times 3x squared minus 7. How many of you made it that far? Okay, good. Now it's just a matter of simplifying it, reducing it. I can multiply this one by 2, which will give me 8x squared plus 38. Multiplying this one by 2 gives me a positive 6x squared and a negative 14. And finally, combining 8x squared and 6x squared is 14x squared. 38 negative 14 is 24. What do you think? Anybody totally lost? Okay. If I just give you this expression like this, can you simplify it? Can you multiply it out? Okay. So that's the main point right here, is being able to simplify it. I'm doing the applications just to kind of give you a little bit of a contrived reason to do it. But the math behind it, the combining it, is the important part at this point. So let's look at another one similar to that, like this. Express the area. Now remember, area is, we're going to do this, width times length, just so you can put the 5x squared first. So area equals 5x squared times our length is 3x to the third minus 2x. So again, all I've done here is I've replaced w with this expression for the width, 5x squared. Then I replace the length, L, with this expression for the length, 3x to the third minus 2x. So how many of you made it to this point okay? Okay. So that's half the battle. The rest of it now is doing the math. What do we have to do? Perfect. We multiply 5x squared times 3x to the third is 15x to the fifth. Good. And then 5x squared times negative 2x is, bless you, yeah, very good, negative 10x to the third. So the area is equal to that expression. Well, we're going to switch gears just a touch. And we're going to talk about, actually, you know what? I think this would be a good time to take our break. Let's go ahead and take our break. It's 9:50. Let's come back at 10 o'clock and we'll switch gears then.